Hi, physics class. Here is your video solution to the 7th problem on our worksheet for Newton's second law. Now, this one's a little bit more complicated, so I want you to go slowly with me through this. Here we're talking about, we have a 5-kilogram bucket hanging by a massless cord from another 5-kilogram bucket, which is also hanging by a massless cord. Now, it tells us the buckets are at rest. That's key. It tells us there's no velocity. It tells us there's no acceleration. An object in motion tends to stay in motion. Object at rest tends to stay at rest. No acceleration, no force on this. No net force on these buckets. So the first thing I want you to do, again, I always want you to draw a diagram. In this case, it's a little bit harder to draw the free body diagram directly, so I want to show you the pieces to doing it. So we're going to put a ceiling on here, and I'm going to put a cord, and we're going to put our first bucket, and we're going to call that the upper bucket. We're going to put another cord, and we're going to put our lower bucket here underneath of it. Okay, so that's just kind of our picture from what it's describing. So now we have to draw a free body diagram for this. So how do we do this? What we need to do is we need to make a free body diagram for each object. For each object. All right. So let's start with the lower one, just because that's going to be easier, right? Because it's not quite as complicated. We can have all the numbers. So let's call F low to be the tension force on the lower cord. So how would that free body diagram look like? So we're going to put our lower bucket, and we're going to put our force from the lower string, and we're going to put our force from gravity down here as well. So we're going to go ahead and do our calculations on this. And we've done one similar to this for doing this one step of this problem. The difficulty here on this problem is we're doing 2 steps. So once again, we're going to start off with our free body diagram, and we're going to sum up our forces so we can get our net force. Right? We look at that. Our F net is our F lower, right? The tension in our lower string is pulling up on our lower bucket, and the force of gravity is pulling down on our lower bucket. Okay. So we know our force. Now, since we know the bucket is not moving, it's not accelerating, we know that A equals 0, right? We know that our F net is 0 here. So now so we know that F low is minus Fg equals 0, means that our F low, the tension in our lower string, is simply equal to the gravitational force on our bucket. 5 kilograms times 10 meters per second equals 50 newtons. So F low, the tension in our lower string, is 50 newtons. Now we got to figure out what's going on with the second string. Now the key thing to note here is that the lower string pulls up on the lower bucket. Key there being pulls up. That's why I just have a direction there with the lower bucket. And it pulls up with the same force that it's pulling down on the upper bucket. Right? So let's use this to draw our free body diagram. So we draw our free body diagram again. Let's put our square out there. Oh, looks like I forgot to put the B high rather for the high bucket, but it's got a tension in the upper string pulling that bucket up. It's got a tension in the lower string pulling that bucket down, and it also has gravity pulling down on that second bucket. So notice here there's 2 forces pulling down on this bucket. The force of gravity pulling down on it, and the force from the lower string pulling down on it. All right. So now again, we're going to do the same approach. Let's use our free body diagram, and we're going to find our net force. So we'll just sum our forces together. We're going to get our net force. What do we see here? F net is going to be equal to, we have F up, right? We have 2 forces pointing down, the force on the lower string and the force of gravity. Okay. Now, once again, we know the bucket's not accelerating, so we know that the acceleration is 0. We know the F net is 0. What does this mean? This means that F up minus F low minus Fg is equal to 0. Right? Sum of our forces is equal to 0. That tells us that our force on our upper string is equal to the force on our lower string plus the force of gravity, right? 50 newtons from our lower string pulling, 50 newtons from our gravity pulling, we know that this force on our upper string, or the tension on our upper string, is 100 newtons. So the key thing here, whenever we have multiple bodies in our free body diagram, draw a free body diagram for each individual object, and then be careful. So like in this case, we had a string, right? The string in the middle, the lower string here, it both is pulling up on the lower box, F low. It's also pulling down on the upper box, F low. Same force, just opposite directions in the two free body diagrams. If you can get that little caveat there, that little complicating factor there, then problems like this become very easy.